Hello there. Welcome to another tutorial. Today we'll be looking at projectile motion. So with projectile motion, what you have is you have a particle, right? And it's being fired in this sort of motion like this, and you can draw the particle there. It would actually be a particle point, but we can just draw it as a circle as a sort of ball to simplify things or to make it clear in a diagram. But it's generally going to be fired. If we actually look at the actual way it's going to be fired, it's going to be fired like this at an angle, and the angle we'll draw at this. The angle will be theta. We'll call it theta, and it's going to have an initial velocity. That's there is the initial velocity. That's the scalar of the initial velocity. Wherein we know in the x direction we're going to have v0 cosine of theta. However, in the vertical, we're going to have like this, and we're going to have v0 sine of theta for the initial vertical velocity. Now, for the next part, what we want to do, we want to actually look at the actual forces on it. Now, if we are going to consider air resistance in a simplified manner. We're going to consider it like B times by velocity. In reality, air resistance is actually more complicated than that. Usually it's actually to do with velocity squared. But to keep this simpler, to make it simple, we're going to avoid that for now. We're going to keep it as b times by velocity, the constant times by velocity, just to make the example more simple, because we don't want to overcomplicate for now. As using v squared will make the integration part of this process harder. But we also need to look at the drag. It's basically, we'll call it the drag force. So drag, I hope that's readable, equals, and it's going to oppose motion. Remember that it's going to whatever direction. You've got two directions. You've got the vertical and the horizontal. So it's going to be a negative b times that times by, and it's a position. It's a vector. Remember, it has direction. Depending on the velocity will depend on what the drag force is. When it's going up, it's going to be when the particle is going. I'll give an example of how that's going to work. So I'll show you what I mean by that. When the particle is traveling upwards, you're going to have it like this. You're going to have mg, like that, mass times by gravity. But you're also going to have the air resistance when it's traveling upwards. However, when it changes and begins falling downwards, it's going to change to this force diagram where it's going to have mg. However, the air resistance is going to act in that direction. So it does very much depend on the direction. That's very important to take that into account. Now, if we move on here to the next part, let's derive the forces. Let's say it out. So we know we have f of x, and we also have f of y. That's not a very good y. I apologize. But yes, it is a two-dimensional plane we are looking at. And we know that for that, we're going to define that as mass times by acceleration of x is equal to minus b times by the velocity vector in the x direction, which is the air resistance in the x direction. Again, b is the constant of the air resistance. It will depend on things like the geometry. B would depend on the geometry of the actual particle and the fluid it's moving through. We're not going to consider wind velocities in this example. We're going to assume there's not a wind velocity, because that would also affect the air resistance equation. However, if the ball travels through water, for example, a different fluid, that therefore has different fluid properties, and that would affect the resistance it's getting. And it wouldn't be air resistance. Obviously, it wouldn't be air resistance, but it would be a fluid resistance, but it'd be a different type. It also depends on things like altitude, even things like altitude, because this is why aeroplanes fly high in the air, because they have less air resistance, because the air is a different density when you go higher up. Anyway, if we go on to the next part, we have mass times by acceleration of y is equal to minus mg, because gravity acts downwards and we're resolving upwards. We're resolving upwards, gravity acts downward like that, like mass times by gravity. So that's very important it's always very important in mechanics problems to know which direction you're resolving. You have to pick a direction and you have to stick to that. Minus b velocity of y. So you see the two force equations there. You got mass times acceleration for x in the x direction is equal to minus b times by velocity of x. And then again, because the velocity that it's currently going at will affect the air resistance. Air resistance is proportional to velocity, well, actually velocity squared, but we're simplifying it with normal velocity. So for the next part now, what we want to do, we want to look at, in terms of calculus, we know that acceleration, we know the formula, we know the formula for acceleration. We know it's equal to dv by dt. We know that. It's the derivative of velocity, we know with respect to time. So with that, we can get it into a format where we can do dvx by dt, and we can put the mass on the other side, because we can just divide by the mass for the acceleration to get it into format equals minus b over the mass by dividing by that, and then you're going to have, again, the velocity in the x direction. We can get it into that format. Now for the next part, what we want to do is we're going to integrate it. So we're going to get into, first of all, let's get into the format where we're going to have integrate between. Now it's going to be between the initial velocity, however, the initial velocity for x, so x of 0, and then it's going to be, and then to velocity, general velocity. That's not very good. V. Let's do that again. V. So it gets into that format of dv is equal to the integral of, we are going to do is the negative integral. We can take the negative number out between, we know it starts at time 0, but time 0 is 0, and time. We know because it starts at time equals 0. We'll assume that to make it, that's how the process starts. Now, the next part we're going to have is b over m vx dt. Now that's not great. We can't actually do anything with that because v is a v. So what we're going to do, we're going to flip that, and we're going to actually divide by vx, and we're going to get into a much better format, which can actually be a lot easier to work with. We're going to get into this format here, v0, v, and we're going to have 1 over vx dv is equal to the negative integral between 0 and time. One second. Hello. Yes. So we're looking at that, and we're going to do again b over m dt. Now, in terms of integrating this part, we know that 1 over vx integrated between of v. By the way, it's dv of x. I apologise. It should be dv of x, dvx. When we integrate that, what we're actually going to get, we're going to get it into a form of ln of v of x. And it's going to be, remember it's between v0 and vx. And that should be, sorry, and one second, sorry about that. It should be, sorry, that should be v of x. It should not be v, not very clear. Anyway, that's going to equal, and then the integral between time 0 and that is just going to be minus b over m t, because that's how you integrate between 0 and time. It's very simple, because you integrate that and it's going to be bmt, and then you plug in t and 0 and 0, and it ends up with just that. If you don't know integration, I can do a video on integration. I can do a video on integration if you want, because I'm not going into detail on the integration in this video, but that could be useful in the future. Now between vx and v0, we know it's going to be ln. One second. Ln of vx minus ln of v0, which can be put into form ln of vx over v0 inside there is equal to minus b over mt. And now we want to just basically, we know that with logarithms and exponential, we can just turn that into form v of x over v0 is equal to e to the power of minus b over mt. And we know that, and we know what v0 is for x. It should be v0x. I apologise, it's quite easy to miss that. We know v0x is equal to v0 times by cos of theta. So the final form in terms of the velocity in the x direction is going to be equal to v0 cosine of theta based on the initial angle it fires at, and then e to the power of minus b over mt, like that. That's the final form, where minus b over mt is an exponential. That's not very clear. I want to make that more clear. It's not clear enough at all. I'm going to zoom in and make that more clear. So minus b over mt. That looks better. Okay. So you've got the final form for velocity in the x direction. Now, if we want to, for example, you see the whole thing there. If, for example, we want to get the position of it in terms of x, so we know that velocity x is equal to, we can get it into this form here. I'll get into the format that's better. We know that velocity x is equal to dx by dt. And that can be equal to v0 cosine of theta times by, and then we have e to the power of minus b over t. We know that from before. We can integrate again, and this integral is a lot easier. If we integrate between... Okay, hello there. For some reason it cut off there. I believe where we got to was the part about dx by dt. So if we look at this, we see dx by dt in that form is equal to v0 times by cos theta times by e to the power of minus b over t. Now we can integrate that. It's going to be between 0 and x. The reason why is because we can assume the initial position of x0 is just 0, just to simplify things. And then for the next part, it's going to be the integral between 0 and time. Again, it starts at time 0, and you're going to get that. You're going to integrate that. When you integrate that, when you integrate an exponential, you just divide by its power. So you're going to get it into this form here. This is the final form of x is equal to minus mass over b times by v0 times by cosine of theta e to the power of minus b over mt. That is the general form of x with respect to time. X as a function of time. That is what it is for the horizontal x position. Now, if we want to look at the y position, we're going to have to do it slightly different. Let's go to a different part of the page. We'll go to the next. We'll go to the second page for this part. Let's go up here. Yeah. So for y, what we're going to look at, basically the same thing, but except we are going to do it slightly differently. We know again that mass times by acceleration of y is equal to minus mg minus b vy, where it's velocity of y. Now, again, we're doing the same thing basically. We're going to divide by mass, and we're going to get into the format of d vy by dt. The integral of that is equal to, and we're going to divide by mass, so it's going to be equal to minus g minus b over m vy. So this is the format we want to get into. That's not a great y, I'll be honest. We can do better than that. Like that. Still not great, but you know what I mean. I do apologise again for my handwriting. It's not really my talent. Yeah, so we've got it in that form now. dvy by dt is equal to minus g, minus gravity basically, minus b over m times by the y velocity, the vector component of y, the vertical part. Now, again, it's the same thing with integration. What we want to do is we want to divide by g. What we're going to do, we're going to take out a factor of minus 1, and we're going to divide by g plus b over m vy. So we're going to get into this format where it's, I'll show you, 1 over g plus b over m times by time. Sorry, not time. My mistake. Times by the vertical velocity component. My y's are doing really bad today. There we go. I guess it's a little better maybe, but anyway, and that's going to that times by dv of y again is equal to minus 1 times by dt, which is going to be just basically, because what we're going to do, we're also separating the terms, so that's dt. As you can see, we've expanded out the terms for the calculus part. And now we integrate now. Now the integral of 1 over g plus b over m of vy is going to equal, I'll zoom in, mass over b the natural log of g plus b over m, like that. And that comes down to the chain rule, like that. And then what we're going to do is we're going to make that equal to, hang on, yes. And that's going to be between, we're going to integrate again between Vy, the initial Vy0, and Vy. So it's the initial Vy0 will be the initial velocity of, the initial vertical velocity, which we defined at the beginning, and Vy. And that's going to be equal to be, again, the integral is going to be between time and 0, because the initial time is 0. So that's just going to be time, just t. Anyway, for the next part, to separate that, it's gonna be the same as before. It's going to hang on, I made a mistake there. Sorry about this. Yeah, the point is that should be b over m Vy. That's the correct form now. Anyway, for the next part, it's going to be basically, you're going to get it into a form basically of m over b ln of g plus b over m Vy over g plus b over m. It's a terrible b. I do apologise. Hang on. I'll just rub that part out. B over Vy0. That's the logarithm we got, like that, and that's equal to time. And you can basically then you put the b over m, so it becomes you put the b over m on the other side, and you end up with g plus b over m Vy over g plus b over m Vy0 is equal to, one second, let me just double check something. I see, I made a mistake. I forgot to keep the dt as negative, sorry. It should be negative t, I do apologise for that. Making a few errors today, I apologise. It should be minus b over m t, like that. And that's the form you get it into. Honestly, man, today's not a good day. I'm making a lot of errors, I do apologise. But it should be, sorry, e to the power of minus b over mt. I don't know why I've made so many mistakes today, but yeah, there we go. So that's the final form you get into, and that's the form you get into, and that's basically the final form for velocity, but in the vertical direction. And you can basically do the same method to get the position vector again, as you did earlier for the other one, where you got the position before we got the velocity. Obviously, for the horizontal direction, we had the x value, and now I've got this mathematics now for the velocity. And again, you can rearrange it if you want into a form that's better. And if we were to rearrange it, what we want to do is times it out, and you can actually get it into a final form of V of y is equal to mass over b, and then inside this bracket it's going to be minus g plus b over m v. Oh, sorry. It's quite hard work on this notes, I'll be honest. It is quite hard. These notes aren't that easy to work on. Hopefully we can get some way better resources if we in future videos. So yeah, the final form you can get it into is V of y is equal to mass over b, and then inside the brackets we're going to open some brackets here. We're going to have minus g plus g plus b over m, and then that's going to be times and by v0 of y e to the power of minus b over mt, and then close the brackets. So that's basically the final form you get, velocity into velocity of y. And you can do this, and then you can just integrate the same way to get it into the position vector, which isn't, it's not that difficult to integrate. You just integrate that, it's, again, we know this is equal to dy by dt. So we know this relation, and therefore with that you can very easily just switch around. Again, y0 is going to be 0. Okay, it starts at 0 at y. We'll assume it starts at y equals 0. So you can then just rearrange that, and you're gonna get into the same format. And all you have to do is integrate the e part, and then it'll be minus g part will become minus gt, and it'll be plus the integrate, and that'll be again minus. You'll also divide by minus b over m, and you can get the position vector for y as well. But that's all. Yeah. Hope that makes sense. Please consider subscribing. And yeah, let me know if you want what kind of videos you want to do. I mean, I'm open to doing any mechanics videos, any maths videos, anything that you need help with. I'm happy to talk about a lot of things. So just let me know what you'd like me to talk about, and I'm happy to do more tutorials. So yeah, thanks again. Thanks.